Investigation, permutations. A login password consists of 3 digits. Knowing the 3 digits is not enough. The digits must be entered in the correct order. John cannot remember the password, except that it has the digits 2, 5, and 9. So what are all the passwords? Well, if I start with 2 and then go 5, 9, that could be one possibility, or 295. Or if I start with 5 and go 29, or it could be 592. And finally, I could start with 9 and be 25 or 952. And you can see, okay, there are 6 possible passwords. There they all are. Now, the other way that we've done this before is using the fundamental counting principle, because I can divide this guessing into 3 stages: the first stage, the second stage, and the third stage. And so for the first stage, I have 3 choices, either a 2, a 5, or a 9. The second stage, I only have 2 choices because I've used one of them. And then the last is 1 stage. And so fundamental counting principle says we should multiply all these together. And so that equals 6 different ways, 6 different passwords. And the next one is something that's new. We're going to be using something called factorials. Now, factorials is the thing that we've been talking about.
No, it's not a math call. They're all meeting there, I think. Just chat.
And it is using an exclamation mark. And we're just going to write 3 factorial, which is 6 ways. So this is a type of arrangement where the order is important. And this is the first time we're going to be using this word, permutation. It's arrangements where order is important.
No.
Where order is important. Okay, and so I've got 3 different ways of talking about this permutation. Some new notations. We're going to use the letter P, capital letter P, and we're going to use the letter N, which is the number of objects, and R is the number of objects that we will arrange. And there's a formula here that we can see that will give us the permutations. And there's also a button on our calculator. I will show you that in a little bit. And then there is a little tip here that says that the N has to be bigger than the R. In other words, if you have 3 things, then you can only select as many as 3 of them at a time. Okay, and so in this case, that is what we have. We have 3 things, a 2, a 5, and a 9. We have 3 things, and order matters, so I use a P, and we're selecting them 3 at a time. And so if I use the formula, that this first 3 is the N, so that will be 3 factorial, and this second 3 is the R. And so I'm going to go 3 minus 3 with the factorial there, which is 3 factorial over 0 factorial, which is 6 over 1, which is just 6. Okay? Now, if this is the first time you're hearing that, there's a math fact that we need to remember. You can even try that in your calculator. It's this weird fact we have to accept to make this work. 0 factorial is just 1. Okay, we're going to try this out one more time here with the word graphite, which has 8 letters. And we're going to try to make 3-letter arrangements with them. So remember, this can be broken into 3 stages, 1, 2, 3. The first choice we have is going to have 8, and then 7, and then 6. Okay, and so if I multiply that together, we get 300. Let me just write the multiplying. 336. And if we use the formula, then it looks like this. The formula is NPR, which is n factorial over n minus r factorial. And in this case, n is 8 things, and we're selecting them 3 at a time. So 8 factorial divided by 8 minus 3 factorial gives 8 factorial over 5 factorial. And then you'll remember that just like we were doing before, if we expand that 8 factorial, and we expand that 5 factorial, we're going to see some canceling. And by canceling, I mean dividing to give us a 1. So we have 8 times 7 times 6, which we've already said is 336. Very cool.